Okay students, so now already we have gone through what is one function and how to show that the given function is 1 and how to show the given function is not 1. Clear? From that, now let us move to onto function, because whenever you are going through some of the concepts, if you want to know the further things, you must be perfect with the before things. Clear? That means if you are perfect with your basics, then you can be very clear with the concepts which you are going to use in your applications. Clear? Without being a clear cut in your actual examples, or before having any applications in any of the tools, you can go through the concept of the basics in detail. That means you must know the concepts in detail before using it in applications. Clear? So for that reason, we already studied one function. Now let us go for onto function. Clear? See here. Onto function. So if you want to define onto function, you must know domain, you must know codomain. In one function also, you must know domain and you must know what is codomain. If you have complete idea of domain and codomain, it will be very useful to solve one and onto. So for onto function, let us consider f being a function from a to b. F being a function from a to b, where a is domain and b is codomain. Here a is domain, b is codomain. A is domain, b is codomain. Clear? So from domain to codomain, you are going to have a relation which is going to be function. Clear? From A to B, you are going to have a relation which is going to be function. Now we are going to check that function is going to be onto or not. Are you getting my point? A relation from A to B is already a function. Now we are checking that function is going to be onto or not. So for that reason, see here, if this is your domain set, if this is your codomain set, let us define f from A to B. Let us define f from A to B. Now, the elements in the codomain, see the elements in the codomain, elements in the codomain must have pre-images, to in domain. That means there must be a pre-image in domain for codomain, that too for every, see here one element is remaining, for that element also there must be an image. There must be an image. Then we say that this particular function is onto. The meaning of onto is every element of codomain must have pre-image in domain. Are you getting my point? Every element of domain must have pre-image, every element of codomain must have pre-image in domain. Then we say that function is onto. Then we say that function is onto. Clear? Suppose if we have a relation of the type, see here, okay, see this is also one of the relation which is already a function, because every element have unique image in codomain, but one of the element is not having pre-image. See here, one of the element is not having pre-image. So for that reason we say it is not onto. For that reason we say it is not onto. But see here, this is onto function. This is onto function, but this particular function is not onto. This particular function is not onto, and this particular function is onto. This is not onto just because there is one element in codomain which is not having pre-image. Clear? This element is not having pre-image, so for that reason this function is not going to be onto. For that reason this particular function is not going to be onto. Here every element of codomain has a pre-image. For that reason that function is going to be an onto function. Clear? So please keep in your mind to show not onto. Again I am repeating, to show not onto you must prove that there is an element in codomain which is not having pre-image, which is not having pre-image. But to show it is an onto, you have to prove with the definition such that for every elements in the domain there is a pre-image. For every elements in the codomain there is a pre-image in domain. See, this is codomain and this is domain. Clear? Now for every element of codomain, if there is a pre-image, then we must say that it is onto. And while proving any function as an onto, again you must be perfect with the definition that for every element in the codomain there is a pre-image. There is a pre-image. So therefore it is going to be an onto function. Clear? That you have to prove in your problem. But for not onto, you must show that there is one element in codomain which is not having pre-image. Therefore that function is called as not onto. Therefore that function is called as not onto. Clear? So that means here one more thing, if it has to be onto, range. See, range must be equal to codomain. Range must be equal to codomain. Clear? If the range is equal to codomain, if the range is equal to the codomain, then if the range is equal to codomain, then every function, that particular function which is having range is equal to codomain, therefore that function is going to be an onto. That function is going to be an onto. Suppose if range is not equal to codomain, then that particular function is not going to be an onto. Are you clear? Please remember, if range is equal to codomain, then it is onto. If range is not equal to codomain, it is not onto. Clear? Okay. So from this, we shall go for some of the problems where you have to show as onto and how to show it is not onto. Clear? Okay. Let us consider a function f. Let us consider a function f from a to b, defined as f of x equal to 2x. F of x equal to 2x. Clear? Let us take a function f of x equal to 2x. Clear? Okay. Here for a, I will give real number set. For b, I will give again a real number set. That means function is a relation from real numbers to real numbers. Domain is also a real number, codomain is also a real number. Now you have to check this particular function is onto or not. Then you have to check this particular function is onto or not. Clear? Okay. So for that reason, I will write f of x equal to y. I will write f of x equal to y. That means the notation, f of x notation, I will write it as y. Y is not a separate variable. This is notation of f of x. Clear? I am notating f of x as y. Clear? So from these two, I will write y equal to 2x. From these two, I will write y equal to 2x. Now x is going to be equal to what? Y by 2. See here. Y equal to 2x. Now x is equal to what? Y by 2. Are you getting my point? So onto tells that for every element in the codomain, there must be a pre-image in domain. There must be a pre-image in domain. So for that reason, see here, x equal to y2 means you choose any real number for y. See, you can choose any real number for y. Are you getting my point? If I choose any real number to y, it will give the value of x, where this x will be present in this R. Are you getting my point? Again I will repeat. See, for every y belongs to codomain, for every y belongs to codomain, that is real number set. For every y belongs to codomain, that is real number set, there exist x belongs to domain. There exists x belongs to domain, that is R. That means that is real number set. Clear? For every y belongs to codomain, a real number, there exists x belongs to domain, again it is a real number. Are you getting my point? Clear? So you can choose any real number from the codomain to this y. That will give you the value of x. That will give you the value of x. Are you getting my point? So it says that for every y belongs to codomain, there exists x belongs to domain. Hence, I can say that it is onto. Hence, it is onto. I think it is very much clear to you. Clear? How to show it is onto? Clear? I have taken f of x equal to 2x. So I will take a notation of f of x as y. This is nothing but notation. This is not anything. It is just a notation. Clear? So this is the notation. F of x equal to 2x is a given function. I will take f of x as y, one of the notation. So y equal to 2x. Please remember, f of x means this is the value of codomain. This is domain R. This is codomain R. Are you getting my point? Domain R, codomain R. Here x terms will be present. Clear? X terms are present. This x will give you f of x in codomain. That means f of x is present in codomain. X is present in domain. F of x, I will write it as y. Please have clarity in everything. F of x is in codomain. X is in domain. So f of x is in codomain. For this f of x, there is a pre-image in domain that I have to prove. So I am proving here. Y is nothing but f of x. Are you getting my point? So for every y, that means your f of x in the domain, there is an element x belongs to domain. Are you clear? So whenever you are proving onto function like this, you have to write each and everything. This thing is not needed, but see, these terms are essential to write in exam. Clear? F from R to R, f of x equal to 2x. This is given. This is given term. I will take a notation f of x equal to y equal to 2x, therefore x equal to y by 2. I know that my domain is real number set. So if I write any real number in the codomain, there exists an element x in domain. If I write this, then that particular function is going to be an onto. Okay. Now let us go for one of the function which is not onto. One of the function which is not onto. Okay. Now let us choose f be a function from natural integers to integers. See, f is a function from integers to integers. F of x is defined as x square plus 1. F of x is defined as x square plus 1. Now we have to check onto for this. So for that reason, let us see what will happen. Clear? Okay. I will write f of x equal to y. A notation. This is a notation. So y is nothing but what? X square plus 1. X square equal to what? Y minus 1. Now x is equal to what? Root of y minus 1. Are you getting my point? So as we go on solving, x will be equal to what? Root of y minus 1. As I said, you have to check your codomain for every element. Is there a pre-image in domain or not? That I have to check. So y is in codomain. I will choose y equal to minus 1. Here. So it will be what? X equal to root of minus 1. This term as minus 1. So x will be equal to root of minus 2. Or you can say that this is okay, root of y minus 1. Y I will take it as equal to minus 1. Y minus 1 it will be minus 2. So we know that root of minus 2 doesn't belongs to integers. Clear? See, clearly root of minus 2 not belongs to z. Root of minus 2 not belongs to z. Therefore we can say that it is not onto. Clear? Because y is minus 1, root of minus 2. Here we have solved as we have to solve. From here I am checking, is there any number in the codomain such that for that number it is going to be onto or not? Clear? So I will choose minus 1. If I choose minus 1, it will be root of minus 2. Root of minus 2 is not an integer. As we all know, root of minus 2 is not an integer, it is a complex number. Therefore, root of minus 2 not belongs to z, hence it is not onto. Clear? First I have proved one of the example to show onto. Next I have shown one of the problem for which is not onto. Clear? Okay, again see, for the same problem, let us take n. Let us take z here or let us take n. No problem. Let us take n. That means natural number set. See, f is in a relation from n to z. I have changed my domain. Clear? You all know n is in a function set that 1, 2, 3, so on. Clear? N is a natural number set which has 1, 2, 3, so on. Clear? This is a natural number set. Okay? So for that natural number set, this particular function is going to be onto or not, that we have to check. Clear? Okay. Is minus 1 belongs to natural number? No, minus 1 doesn't belongs to natural number set. Clear? So for that I can't take y equal to minus 1, but no problem. See here, again come to z. Z has minus 1, that belongs to z, minus 1, that belongs to z. So that for that we have already discussed. If I take minus 1, what will be your element? See, x equal to root of minus 1 minus 1, it will be equal to minus 2. Again minus 2 doesn't belongs to natural number set. Minus 2 doesn't belongs to natural number set. Again this is not on 2. Are you getting my point? Again this is not on 2. Are you clear? Okay. So for that you have to prove like this. Clear? Or directly you can write range is not equal to codomain, or directly you can write range is not equal to codomain. From this also you can write. See, after all writing this, you can write that range is not equal to codomain, hence it is not on 2. Hence it is not on 2. Clear? After writing this, range is not equal to codomain, therefore hence it is not on 2. Okay, no problem. Again let us go for the next. I will change it as n. I will change it as n. Now let us see what will happen. Clear? Okay. Let us check what will happen if I take n here. Are you getting my point? If I take n here, is it going to be onto or not? Let us check. Okay. Again I will take 2 belongs to natural number set. Here 2 belongs to natural number set, 3 belongs to natural number set, 4 belongs to natural number set. Are you getting my point? Okay. If I take 2 here, what will happen? See here, what will happen? Y equal to 2, because this 2 is in codomain. I am checking the image, pre-image of 2 from codomain. Are you getting my point? So if I take y equal to 2, which is in codomain, what will happen? Let us see. See, put here 2. What will happen? X equal to y divided by 2 minus 1. So that will be what? X equal to root of 1. See, root of 1 means nothing but 1. Root of 1 is nothing but 1. But no problem. For this element there is a pre-image. Are you getting my point? For this 2 there is a pre-image. No problem. Suddenly don't write it is on 2. After checking this, okay, I have got 1 will be present in n. Like that you don't think. Again think more times. Directly you can't write anything. Okay. So if I take 3, what it will happen? If I take 3, y is equal to 3, it will be equal to what? 3 minus 1. 3 minus 1 is equal to what? Root 2. Therefore, if I take 3 from the natural number of codomain, then I will get root 2. I know that root 2 again doesn't belongs to natural number set. Root 2 again doesn't belongs to natural number set in domain. Therefore, I can write it implies range is not equal to codomain. Again I can write range is not equal to codomain, hence therefore it is not on 2. Hence therefore it is not on 2. Okay. So from this we can say that how to prove on 2 and how to prove not on 2 you must know. Are you getting my point? Okay. If I write with any another set you can take and solve. You can take for C to C and you can see complex numbers to complex numbers. But we always read real numbers as real numbers as a concept in our relations functions. There we can't use complex numbers and we are not going to deal with that type of any particular examples. So for that reason, no problem, you don't try from C to C, or it is your interest, you can try from C to C what will happen. Okay. So this is what about onto function, how the onto function must be and how the onto function cannot be, and how onto function has to be proved and how onto function can be disproved. That means how you can say it is not onto. How you can say it is not onto. If you know all these terms, it will be very useful for our further problems. So for that reason, please be perfect on this. Okay students, so now let us summarize the things of 1, and onto. Let us summarize the things of 1, and onto. That is conditions for 1, and onto function. Conditions for 1, and onto function. Okay, see here. First thing, for 1, what we have to do? First thing is, if f of x1 equal to f of x2, if f of x1 equal to f of x2, it implies x1 equal to x2. This must you have to prove to show 1. Next, second one. If f of x1 is not equal to f of x2, if f of x1 is not equal to f of x2, you must imply that x1 is not equal to x2. x1 is not equal to x2. Clear? Okay. If f of x1 is equal to f of x2 implies x1 equal to x2, if you prove both of this, then it is going to be 1. And if f of x1 is equal to f of x2, but it implies x1 is not equal to x2, then it is not 1. Then it is not 1. Are you clear? F of x1 is equal to f of x2 but implies x1 is not equal to x2, then it is not 1. So these are the conditions for 1 function. Okay. Now let us go for onto. Now let us go for onto function. First thing, see. We have to show that for every y belongs to codomain, there exist x belongs to domain. There exists x belongs to domain. This we have to prove. Clear? If you prove this, then the function is going to be onto. That means for every y belongs to codomain, there exists x belongs to domain. That you have to prove. This will imply range is equal to codomain. This implies range is equal to codomain. Are you clear? So this is the condition for onto which you have to prove. Okay. Then for not onto, what we have to do? We have to show that range is not equal to codomain. We have to show that range is not equal to codomain. This is for not onto. Are you clear? So if range is not equal to codomain, therefore that particular thing is going to be not onto function. If range is equal to codomain, then that function is going to be onto. Okay. So from this we can say that these are the conditions to show 1 and not 1, onto and not onto. With these particular things you must be perfect. Okay. I think now 1 and onto both the functions are very much clear. So in the next session I will continue with bijective function.